Thank you very much. My name is Patrick Twinamasko. I'm in evening class, and today I'm recording this video on coursework for embedded system, and the project is called Smart Parking. So in this smart parking, we have also embedded the warning system. Thank you very much. I will take it briefly. This is the general setup of the project. This is the general setup of the project. If I can see the components, we have the Arduino circuit. We have 3 LED lights. Okay, let me first stop simulation. We have the 3 LED lights. These ones are controlled by the resistors of 220 ohms each. We have a buzzer. This one is a sound output to output warning signals. And for this project, it will be outputting the warning signals if the car delays in the parking slot. We have the sensor. This sensor will be sensing an incoming vehicle in a distance of 15 meters. Once a vehicle comes and it's within a distance of 15 meters, this vehicle will sense it, as we shall see. We also have a screen. This screen displays if the slot is available or not. Okay, we have a switch. This is a push switch. This push switch will be put in the slot, in the parking slot at the front tires. The idea is when the vehicle is entering a slot, it will be detected, but the slot will not yet be fully occupied until the front tires places this micro switch, this push switch. We also have a potentiometer to regulate the voltage that is going to the LCD. So I'm going to start a simulation. Later we shall explain the code. Okay. All right. You heard the first sound, a buzzer saying that the LCD is on and the parking slot is free because there is no vehicle detected, and the green light is on. The rest all are now low, low, low. Let us see. When a vehicle is coming, is at a distance of 130.3 centimeters. This green is still high and the parking slot is still free. Yellow and red all are still low, low, despite the vehicle being seen coming. So as the vehicle approaches the parking slot at a distance of 15, let's say again, it's back. At a distance of 15 and less centimeters, the green light is still on, but the car has been detected. There is a car detected. So this vehicle, it approaches, the car is still detected, and the slot is still free until the front tires presses the push button. If the front tires presses the push button like this, no car is detected because no car is within that range. So we see that at that distance, okay, at that distance, the car is detected, and this the standard. Very good. This means that we saw the LCD counting down. The buzzer is on, meaning that time time exceeded. The red came on when the space was occupied. The yellow is blinking to alert you that please you have exceeded timing. That is the idea behind this. Thank you very much. This one will go on provided the time has exceeded until the vehicle moves away. If the vehicle moves away, then we see the vehicle moving away, everything, the parking slot is free again. But when the vehicle comes 50 centimeters, it is detected until the push button is placed. When the push button is placed, yeah, red comes on and the countdown starts. The slot is occupied. But if the countdown goes up to 0, then the blinking will come on and the yellow, or rather the buzzer, will start warning you. This will go on provided the obstruction remains on until this car goes back and the parking slot is free again. Thank you very much. I can take you briefly through the code. Let me take you briefly through the code. We have coded using C++ as the coding language. Now we have included liquid crystal. Let's go. The ultrasonic sensors. The trigger pin here. Let me see if we can see it. This one is connected to pin 9. The echo, to bring out the echo, is in pin 10. The LED lights, these ones are in the pin 2, 3, and 4. We can see it here. This one is in pin 2, the black in 3, and this one in pin 4. The push button is in pin 7 rather. Let us see the push button. The push button is here, and it's the blue one in pin 7, like that. The buzzer has a number of pins, but RS is in pin 12, E is in 11, D4 is in 5, D5 is in 4, D6 is in 3, and D7 is in 2, or as seen here. This is what we are talking about, all these ones. The parameters, let us not talk much about it, but we can define them. Defining the distance threshold 15. This is where I was talking about at this point, where I was saying it must detect within 15 centimeters. This is what we are talking about here. It must detect within 15 centimeters. If it goes back, no detection. Time limit 1000. These are 10 seconds. It makes a countdown once the push button is pressed. For 10 seconds, there is a delay of 200 and the bounce delay of 50. Let's see the variables. The variables, we have a duration of time. We have int distance. Slot occupied. Initially, it will be false. Car detected false. Alert active will be false. Okay, we can go on. Button state. It will take the last button state will be high. That is if the vehicle places it, as I explained. Let us see the setup. Initial setup begin at 9600. Then it will print on the serial monitor smart parking detection plus confirmation. It will initialize until it is detected and then confirmed. Then we see the pin mode. We shall output a green output. We shall also output a yellow. We shall also output a red. Okay, and the push button will be inputting the signals. The buzzer will output the sound. Okay, digital write. We shall have green, red, high. Initially it will be high, that is by default, and the rest will be low, low, low. Okay, let's see on the LCD, on this, on the LCD screen, on the LCD screen, on the LCD, LCD is in pin 16. Okay. The cursor initially will be at 0. It will print smart parking here in the serial monitor. Then system ready. We shall hear the click. The buzzer tone will come and it will be at 1000. Here, if we reduce here, then it will also reduce the intensity of sound, and the delay will be only 0.25 of a second. Okay, so the system, the serial print, here on the serial monitor, it will print a system initialized. We shall see that. Waiting for a car, we shall see. Then when it is initializing, we shall also be seeing that. The delay will be 2 seconds. Let's see in the loop. We shall have the distance will equal the measured distance. This distance we show this side will be as per it is measured. We saw that when it was increasing and reducing up to 15 centimeters. Current car detection will equal to, it will detect provided the distance is less than the distance threshold. And we say the distance threshold in this matter is 15. That's what we have seen, is 15. Okay. Provided the distance is less than 15 and greater than 0, then we shall see car detected. If the distance is at 0, then we shall have an error. Okay. We shall have, if the car is detected, if it is true, we shall have a buzzer outputting a sound at 800 decibels. Then the screen will print car detected in a parking area. Yes, or else, if the slot is not, if it's before confirming it, if this car it tries to detect and it's not detected, then it will say car left without confirming parking. And if it does that, the button pin we saw there, the push button, will read the input that will come. Okay, if the reading is not equal to the last button state, then the last button state will take will equal to mils. We can see, let's quickly go to, if the slot is occupied, if it is updating the system now. If the slot is occupied, green will be low and red will be high. We saw this. If alert active, that is the yellow, is active, that is if the vehicle has spent more than 10 seconds, yellow, it will blink yellow, and there will be a buzzer alert, the sound. In that case, if it's not exceeded, then the yellow should be low and there should be no tone in the buzzer. Then if the car left without pressing the button, it should also show that car left without checkout. Now it means the slot is not occupied, car is not detected, alert is not on, and a pin will ding but at a small 1500. Else, it means if the car was detected, this means that the green light will now go high. If it left while it was detected, it means the green light will go high again, implying that the slot is available, like now how it is. The red and yellow plus the buzzer all will be low, low, low. On the screen, rather on the serial monitor, it will print the distance, and this distance will equal to the distance that will be measured, but it will be in centimeters. And then car detected. The serial monitor will also print if the car is detected, yes or no, it will show it. If the slot is occupied, yes or no, it will also show it. Okay. That is basically what we are looking at. That's basically what we are looking at. Yes. And I may maybe explain something here on if the slot is occupied. The LCD, let me talk about the LCD. The LCD will be showing the parking slot free. Initially, will be showing the parking slot free. Else, if